Good morning, all of you. So, last class we have discussed about carbon ions, reactive intermediates in organic synthesis. So, block 2 is complete, aldehydes and ketones and carboxylic acids and carbon ions. Okay, block 2 is organic part is complete. So, then we are discussing about inorganic. Okay, in inorganic chemistry, so there are three units are there. So, first is group 6 elements, and second one is group 7, okay, seventh group elements, and third is zero group elements. Okay, sixth group is oxygen, and seventh group is start with fluorine, and eighth group is start with helium. Okay, so we're discussing about second unit, halogens. Okay, seventh group elements are also called halogens. So halogens means, okay, so like simple fluorine, chlorine, and bromine, iodine, and astatine. Okay, na? So these are all are called halogens. Halogens. Okay. So in this lesson, we are discussing about introduction. Okay. Objective. What is the objectives of halogens and introduction? Properties. Okay. Properties of halogens and comparative study of elements. Okay. In between fluorine, chlorine, bromine, and bromine, iodine. Okay. So what is the comparisons between these elements? And covalent character. Covalent, okay, now what is the bond between this metal and hydrogen? Okay, covalent bond character. And halogen hydrides of hydrogen halides. Okay, hydrogen halides are halogen hydrides. HCl, HF, HBr, HI, like this. Okay, hydrogen halides. Hydrogen halides are halohydrides. Then oxides of halogens. Halogens, okay, treated with oxygen. Okay, na the commonly called oxy. Okay, now oxides of halogen. Oxides of halogen. Then interhalogens. Okay, between these two halogens, like this ICl3, IF5, between the metal bond between these two halogens, that is called interhalogens. Then pseudohalogens. Okay, pseudohalogens. Then polyhalides. Okay, polyhalides, and basic nature of iodine. Finally, okay, now these are the parts. These are the parts we are discussing in this lesson. Okay, so what is the objective? What is called halogens and what properties in this lesson? So very important is interhalogen compounds and pseudohalogen compounds and oxides of halogens. So these are the three topics. Okay, so these are the three topics are very important in this lesson. Okay, these are the three topics are important in lesson: oxides of halogen, interhalogen, and pseudohalogens. Okay, na? In every exam covered from these topics only. Okay, see the objectives. Okay, see the objectives. We are entering into the lesson. The purpose of this unit. Okay, now what is the purpose of this unit? You understand the various aspects of group 7th A elements and justify the similarities and differences in their properties in terms of electronic configuration of the element. Okay, in 7th group, general electronic configuration is NS2-NP5. NS2-NP5 is the general electronic configuration. Is NS2-NP5. Okay, see, account of for the variable oxidation state of elements except fluorine in the terms of electronic configuration, and explain the different colors. Okay, different colors exhibited by halogen molecules and also their physical properties, physical state. Okay, so explain the extensive hydrogen bonding in HF molecule, hydrogen bonding in hydrogen and fluoride molecule. Okay, hydrogen and fluoride molecule, and rationalize the decreasing oxidizing power of halogen from fluorine to iodine. Oxidizing power decrease from group top to bottom. Okay, top to bottom decrease the power. Next one, account for the decreasing reactivity of hydrogen halide in descending in the group. Okay, now reactivity of hydrogen halides HF, HCl, HBr, HI, like this. Okay, na? And decrease the reactivity order and appearance of the difficulties encountered in the isolation of fluorine. Okay, na? Isolation. Isolation means synthesis. Isolation means extraction. Isolation means extraction of fluorine. Extraction of fluorine. So, what is the difficulties for the extraction of fluorine? So, in this also we are discussing in this objective of the lesson and account for the increasing acid strength, hydrogen halides, acid strength from top to bottom. Oxidizing power is decreased. Acid strength is increased from HF to HI. Aqueous solution in aqueous solution. So these are the objectives covered in this lesson. So what is the general electronic configuration? NS2 NP5. NS2 NP5 is the general electronic configuration for halogen or 7th A group elements. 7th A group elements. Clear? Next, we are discussing about, so see the introduction. See the introduction. Oh, so okay. The group 7th B comprising halogens is often considered for the one of the best group for the comparative study. Okay. So ivanni kuda, so this series, the N general, 1 minute. The electronic configuration of element is NS2 NP5. This is the general electronic configuration. Okay. Electron chart of the noble gas configuration. One electron chart. What is the noble gas configuration is NS2 NP6. So 1 electron chart for the noble gas configuration. 1 electron chart to the electronic configuration. So the chemistry of halogen is dominated by their tendency of complete the octet and to form ionic compound with metals. Okay, now what is the main activity dominated by their tendency to complete the octet? Octet means 8 electron. Octet means 8 electron. So first one is ionic compound with metal. Ionic compound with metal containing the negative halide ion. Okay, now negative metal with chloride, metal with fluorine, metal with iodine, metal with bromine. It contains negative charge. And second one in this ionic form. But in covalent compound with non-metal, they treated as with non-metal. So further, halogen from bridged compounds in which there are coordinates such as Al2 and Br6 and KHF2. Al2, Br6. Okay, now in bromine, it is a bridging ligand in Al2, Bl6. Like Al, like the structure is like this. Br, and Br. Okay, now the bridging halogen ligands are act as a bridging ligands also. Okay, see what are the fluoride ligands in this? See halogens. What is the property and what are the fluorine, chlorine, bromine, iodine? We are discussing about halogens is showing as X. Okay, now halogen showing as in all the. Okay, if Rx, that is alkyl halide, X means we are called halide. X is fluorine, chlorine, and bromine, iodine. Okay, now these are the complete halogens. Okay, C property. You know that atomic number. Okay, now atomic number of fluorine is 9. Atomic number of fluorine is 9. So we are adding 1, 8, 17. Then adding 18, 35. Then adding 18, 53. Okay, now like this. Okay, 8, 18, 18. Simple. Fluorine is 9. Okay, now basic fluorine is atomic number 9. Just we adding 8. Okay, now we adding 8. 17. Chlorine is 17. And bromine, we adding 18. Bromine is 35. Then we adding another 18. So iodine is 53. Atomic number is 53. You have to know all of them, just electronic configuration. See this. NS2, NP5. NS2, NP5. See, 2s2, 2p5. 1s2, 2s2, 2p5 is fluorine. 1s2, 2s2, 2p5. Last electron, valence electrons are NS2, NP5. 2s2, 2p5. Valence electrons are 9. Then chlorine is 3s2, 3p5. 3s2, 3p5. But bromine, 3d orbital is there. Okay, na? 3d period is generated. 3d10, 4s2, 4p5. 3d10, 4s2, 4p, 5. Then iodine, 4d10, 5s2, 5p5. 5s2, 5p5. So in all this, what is the general electronic configuration here is showing? NS2, NP5. NS2, NP5. Okay. See, the atomic weight is equal to 19. Fluorine is atomic weight. Atomic number is 9. Okay, now atomic weight is double or more than. Okay, now double or excess. Okay, now little bit excess. See, fluorine is 9. Exactly double means 18. So, but atomic weight is 19. And chlorine is 17. So double we get 34. But here chlorine we get 35.5. 35.45 is nothing but 5. Then bromine is equal to 80. 79.9 means 80. Bromine is 80. And iodine is 127. Iodine is 126.9 means is equal to 127. 127. Okay. So these are the important, okay, atomic number, electronic configuration, and atomic weight. Atomic weight. See, another important point, this one. This is very, very important. Okay. Electronegativity. Electronegativity. So in periodic table, highest electronegative atom is fluorine. Highest electronegative atom is fluorine. So the value is 4.0. The value is 4.0. Then chlorine is 2.85. 2.85, second highest. Okay. Then bromine is 2.75. Then iodine is 2.20. Okay. So from this, fluorine, and bromine, iodine. So fluorine is 4.0. Chlorine is 2.85. Bromine is 2.75. And iodine is 2.20. From this, what we are understanding, in groups, electronegativity value top to bottom is decreasing. Top to bottom is decreasing. So okay, now we are understanding is electronegativity in this group. Okay, now from top to bottom decreasing. Okay. Next another important point in from this, electronegativity is over. Then see, and the melting and boiling point. So is fluorine is melted minus 220 degrees. Okay, na? Minus 220. And boiling point is minus 188. Okay. So all are in negative ways. Okay, na? Fluorine also 101 and 34.5. Bromine also minus 7.3 degrees. Okay. And 59 degrees. Okay, na? Boiling point is 59. Iodine is 113. Iodine melted 113 degrees. And boiling point is 183. Okay. So these are the important okay. And these also important. Okay. Next important one is oxidation state. Oxidation state. Okay, na? Fluorine shows -1. Okay, na? It always shows -1 oxidation state. F minus. We always write F minus. Okay, na? We always write F minus only. Okay, na? Not positive, only F minus. But chlorine shows different. -1, 1, +1, +2, +5, +7. Okay, now it will shows -1, 1, 2, 5, 7. And bromine also -1, 1, 3, 5, 7. And bromine and iodine is same. Bromine and iodine show same oxidation state. Okay, same oxidation state. See, F, we always write CF minus, and we always write Cl minus, but sometimes Cl +1, +2, +4, sorry, +2, +5, +7, based on the compound. See, what is the color of the compound? Fluorine is pale yellow. Okay, now fluorine is pale yellow, and chlorine is greenish, and bromine is reddish, iodine is black. Okay, now if they increase the temperature at 20 degrees, okay, now increase the temperature at 20 degrees, fluorine act as a gas, and chlorine also yellow gas, and reddish brown liquid. Bromine is a liquid. Bromine and okay, in periodic table there are two liquids. There are bromine and mercury. Okay, na mercury and bromine is a only two liquids in periodic table. Okay, then iodine is blocks. Iodine is at 20 degrees. It acts as a solid. Okay, na. So these are the properties of halogens. Only these are the important. Okay, na. No need to write all of this. Just what is the atomic number and what is the electronic configuration and atomic weight. Then electronegativity and oxidation state. Then we are further studying into boiling and melting. Okay. So no need to write all of this in exam purpose. Okay. So complete of these properties. Next, we are discussing about comparative study. Okay, na? Comparative study. So no need to like this. Okay. So important one. These are the important. Okay. Oxides of halogen. Important one. You have to write this completely. Okay, na? You have to write compulsory this one. Oxides of halogens. Halogens do not combine directly with oxygen. Halogens do not combine directly with oxygen, but halogen oxides are prepared by indirectly. How? Most of oxides are unstable except OF2, oxygen difluoride. Okay, na? Oxygen difluoride. Compounds of oxygen and fluorine are oxygen fluoride, but not fluorine oxide due to the high electronegativity of fluorine. Since oxygen is more electronegative than other halogens, they are called halogen oxides. Okay, na? Oxygen is 3.5. Okay, na? Oxygen is 3.5. So halogens kante, okay, na? Other halogens, okay, na? Other halogens, because chlorine is 2.85, bromine is 2.75, iodine is 2.0. Okay, 2.20. Okay, now when compared to this one, oxygen is more electronegative. So that's why they bind with only fluoride. Oxygen fluoride is firstly. Okay. See, what is the oxides? OF2. Oxygen fluoride monoxide. Okay, now OF2, oxygen is difluoride. It is prepared by passing F2 through NaOH solution. NaOH solution. Wait. Okay. So OF2, oxygen difluoride, it is prepared by passing F2. Okay, na? F2 through NaOH solution. F2 gas by NaOH solution. See the reaction. See 2F2. Okay, 2 moles of F2 reaction with sodium hydroxide. 2 moles of NaOH. It gives 2 moles of sodium fluoride plus water molecule, and we are OF2, oxygen difluoride, monoxide. Okay, na? Oxygen difluoride or monoxide. It is pale yellow, poisonous gas which is stable. Okay, na? Poisonous gas which is stable. It decomposes on heating. It releases H2 gas. Sorry, it releases O2 gas and F2. It's soluble in water slowly. It is a strong oxidizing agent and liberate halogens from their salt and acids. Okay, na? So these are the important one. Oxygen difluoride. Next, okay, see the structure. O2 F2 dioxide. So okay, na? O2 F2 and BrO2. Okay, so these are the important. So we are discussing about interhalogens, the binary compounds formed by union of two different halogens under suitable conditions. Okay, na? The binary compounds, interhalogens formed by union of two different halogens under suitable conditions of temp and pressure. Okay, na? Of temperature and pressure are known as interhalogen or interhalogens compound. Interhalogens are interhalogen compounds. The binary compounds formed by union of two halogen. Okay, na? So the binary compounds formed by union of two different halogens. Okay, not same halogens, two different interhalogen within the halogens. Okay, so two different halogens under suitable conditions of temperature and pressure, and temperature and pressure are known as interhalogens compounds. Okay, so the main reason for the formation of these compounds is large electronegativity and the size difference between two halogens. Okay, the main reason for the formation of this compound, why the interhalogens compounds are formed, because the large electronegativity and size difference between two halogens. Thus, fluorine, due to high electronegativity and small size, forms maximum number of interhalogens called halogen fluorides. Generally, okay, so this is the important one. Okay, in exam pattern. Okay, so generally the large atom is the central atom, and the number of interhalogen with more than two halogens atom been prepared. The oxidation state in interhalogens increase in atomic number. Interhalogens are more reactive than halogens. Due to weak bonding in them. Halogen with high electronegativity is taken as anion. Then that's why all fluorine compounds are fluorides. Bonding in interhalogens is generally covalent due to small electronegativity difference. Interhalogens are divided into 4 types, which are about 11. Okay, which are about 11. The oxidation state of various from చూడండి ఇక్కడ ఉన్నాయి ఏంటంటే క్లియర్ గా +1 +3 +5 +7. Okay, so very important, interhalogens. What is the definition of interhalogens? The binary compounds, binary means two, binary compound formed by union of two different halogens under suitable conditions. What is the suitable conditions? Suitable temperature and suitable pressure. That is known as interhalogens or interhalogen compounds. Why the interhalogens form? The main reason for the formation of these compounds, large electronegativity and size difference between two halogens. Thus, fluorine has high electronegativity and small size. Okay, now in group, top to bottom size increase, electronegativity decrease. So, fluorine, chlorine, bromine, iodine. This is high En, small size. Okay, na? Fluorine is high En, small size. Iodine is big size and less electronegativity. Okay, so that's why the main reason for the formation of this compound, large electronegativity and size difference between two halogens. Thus, fluorine, due to the high electronegativity and small size, forms maximum number of interhalogens. Okay, na? Which is electronegativity high and small size. Fluorine will form more interhalogens. Called halogen fluorides. Halogen fluorides. Generally, large atom is the central atom. And number of interhalogens with more than 2 halogen atom has been prepared. The oxidation state in the interhalogen increase with increase in atomic number. Okay, na? Atomic number increase, oxidation state will also increase. Interhalogens are more reactive than halogens. Increase with increase in atomic number. Interhalogens are next. Halogen with high electronegativity taken as anion. Halogen with high electronegativity. In these two interhalogens, which is more electronegative, that is taken as a anion. Okay, that is why all fluorine compounds are fluorides. So in the 4 halogens, fluorine is the highest electronegative atom. So all fluorines are called fluorides. Bonding in interhalogens is generally covalent bond. Okay, interhalogens lo the bond enti, what is the bond? Covalent bond due to small electronegativity difference. And interhalogens are divided into 4 types, which are about 11. Total compounds are 11 compounds. Okay. The oxidation state, okay, na? In AB plus 1, AB3 plus 3, AB5 plus 5, AB7 plus 7. Okay, na? So this is the different variable oxidation states. See, CLF in AB type, CLF, okay, na? Fluoride. BRF, bromine fluoride, bromine chloride, iodine chloride, and iodine bromide. Okay, CLF3, chlorine, tetrafluorochlorine, okay, na? Trifluorochlorine, BRF3, IF3. In AB5, only 2, BRF5, IF5. In AB7, IF7. AB is linear. AB3 is so different. They show different structure. These are the classification of interhalogens. Okay, na? What is the definition and how they form and why they form, and what is the classification, how they show electronic oxidation state. The compound formed AB and AB3 type. Those where electronegativity difference is not large, AB and AB3. But the compounds AB5, AB7 are formed by big atoms. Like bromine and iodine with small atoms. Like, okay. So how the preparation of interhalogen? Okay, na? Interhalogens prepared by following methods. So first method is by direct combination. See, direct combination of 2 halogens in a nickel tube. Okay, na? In a nickel tube at different temperature form interhalogen. So see, Cl2F2, direct. Chlorine and fluorine, equal value. Okay, na? 1:1, equal value at 200 degrees centigrade. In nickel tube. Okay, na? We are introduced into the chlorine and fluorine into nickel tube at 200 degrees centigrade. The formation of CLF. Okay, na? AB type interhalogen. AB type CLF. Second one, Cl2 plus 3 moles 3F2. Okay, na? 3F2, 3 moles of F2 and 1 mole of Cl2 at 300 degrees centigrade. It forms ClF3 and AB3 type. ClF3 means AB3 type. So these are the interhalogens, all the preparations, number 1 and number 2. By the action of a halogen on lower interhalogen. See, higher interhalogens are prepared by the action of halogen on lower interhalogens. With the lower NIO. Example, see, Cl2 Cl2, chlorine gas, plus what is the ICl? That is a lower interhalogen, lower AB type, lower interhalogen, ICl, iodine chloride, and with formation of ICl3, AB to AB3 type. We get AB3 type. Okay. Next one, the preparation of IF7 like this. IF5, it is a interhalogen, lower interhalogen treated with F2, formation of IS7, AB5 to AB7. Okay, now what is the method preparation? By the action of halogen on lower interhalogen, Okay, now so this is preparation methods. Okay, this is the preparation methods for interhalogen. Very, very important. Okay, na? Very, very important. Interhalogens are in every exam. Okay. See, next one. General properties. So, properties of interhalogen. They ask in exam what is interhalogens and preparation and classification. Preparation and classification of interhalogens. Okay, AB type, AB3, AB5, AB7. AB3, AB5, AB7. Okay. All interhalogens see general properties. All interhalogens are volatile. All interhalogens are volatile. Few are unstable but not explosive. Few are unstable but not explosive. Okay. All volatile. Volatile means number of applications of the interhalogens, and few interhalogens are unstable but not explosive. They're not explosive. Second property is all are exothermic with low heat of formation. Exothermic means it releases heat. Okay, na. Endothermic means absorbed. Okay, na. Absorbed by the surroundings. And that is the endothermic reaction. Exothermic means it in the reactant convert into products and release also one something energy as a heat. That reaction is called exothermic reactions. All the exothermic with low heat of formation. Okay, na? So these all reactions are exothermic, but it releases small amount of heat. Third one, interhalogen containing fluorine. Interhalogen containing fluorine are colorless compounds. While with heavier halogens atoms are colored. Heavier atoms like iodine, bromine are colored compound. With lower fluorine atoms are colorless. Intensity of color increase with increase in molecular weight. Intensity of color will increase. Molecular weight. Fluorine molecular weight is 9, atomic number 9, molecular weight is 19. Fluorine is 17, 35. Bromine is 35, atomic number, molecular weight is 80, and iodine is 53, 127. Okay, na? So from top to bottom, atomic weight increase. So the intensity of color increase in the molecular weight. Molecular weight increase, the intensity of color will also increase. This is the third property. Next, fourth one, compared of type AB type, CLF, ICL, like this example, resemble halogen in physical properties. Different properties like melting point and boiling point. Okay, na? Melting point and boiling point increase with increased electronegativity difference. Okay, na? Electronegativity difference will increase. The melting and boiling point also increase in between interhalogens. For example, ICL. So this is 2.20, 2.75. Let's see. Go. ICL, IBr, CLF. ICL, IBR. So this is 2.85. The difference is more. Okay, na? The difference is 0.65. The difference is 0.65. In IBR, 2.20 and 2.75. Okay, na? The difference is 0.55. In this iodine chloride, iodine bromide. In this iodine chloride, iodine bromide. See, what is the point? Compounds of type AB resemble halogen in physical properties. Difference in properties like melting point and boiling point increase with increased electronegativity difference. Okay, na? Which is more electronegativity difference? The ICl more electronegativity difference when compared to IBR. When compared to IBR. So in these two, this is more melting and boiling point. This is more melting and boiling point when compared to IBR. Only in AB type. Only in AB type. Okay. So this is the point. Okay, na? In between iodine and chlorine, electronegativity difference is 0.65. In iodine and bromine, the electronegativity difference is 0.55. So electronegativity difference is large. Melting point and boiling point also will increase. So this is the point number 4. Point number 4. Okay. Then number 5. Due to difference in electronegativity, values, they ionize and conduct electricity as the polar covalent. Okay, na? Electronegativity difference, they conduct electricity. What is conductance means? Okay. So the flow of current, okay, na? Flow of electrons is current. They pass the current through this solution, that is a conductor, good conductor. Okay. So due to difference in electronegativity values, they ionize. Ionize means in solution, they are dissolved into plus minus. They dissolve into, okay, na? They dissolve into, deionized into plus and minus. So plus the ions are formed. What is ions? Ions are formed. They conduct electricity. Okay, na? Ions are formed. They conduct electricity as they are polar covalent. Okay, na? Polar covalent. Polar means positive and negative. Then 6th point, they are more reactive than halogens. Okay, na? Halogens are fluorine, chlorine, bromine, iodine. Interhalogens are between 2, ICl, IBR, okay, na? IF5, BRF3, IF7. Okay, na? These are the interhalogens. Halogens are fluorine, chlorine, bromine, iodine, which are more, okay, na? The more reactive than halogens. Halogens kante ekwa reactive interhalogens due to weak bond. Greater the difference in electronegativity, higher the strength of bond, more polarity and stability. Electronegativity ekka unte difference, okay, na? Difference, more okay, na? More strength of bond. Okay, na? See, iodine and fluorine. Iodine is 2.20, fluorine is 4.0. So the electronegativity difference is 1.80. Okay, na? 1.80 difference. And bromine, chlorine is just 0.1. Chlorine is 2.85. Bromine is 2.75, just 0.10. And bromine and fluorine also electronegativity difference is more. Okay. So what is the concept is the more electronegative, the more reactive halogens due to weak bond, greater the difference in electronegativity, higher is the strength of bond, and more polarity and more stability. So this is iodine fluoride is more stable than BCl, is more stable than BRFI, ICl, IBR, and BRCl. These all are AB type. Then 7 point, they behave as oxidizing agents. And attack most of elements producing mixture of halides. Okay, na? Attack producing mixture of halides. See, ICl plus 2 moles of sodium. Okay, na? They form NaCl and NaI. Sodium chloride, sodium iodide. Mixture of halides అనేది వచ్చినాయి. అంటే sodium chloride and sodium iodide. They behave as an oxidizing agent. Okay. Next, halogen fluorides are more reactive and used as fluorinating agents. Fluorinating agents like ClF3, BrF3, and IF5. IF5. Next, okay, so these are the enough. These points are they are alkenes and form addition product. Alkenes treated with interhalogen, they form addition product. Okay, all interhalogens are diamagnetic. All interhalogens are diamagnetic, which indicates that electrons are paired or unshaded pairs. Okay, now diamagnetic means all the electrons we should be paired in orbital. In orbital, that is all are diamagnetic property. Okay, they are hydrolyzed to form halides and oxyhalide ion. Halide forms smaller and more electronegative element, while oxyhalides is form larger and less electronegative element, hypoiodous acid and bromic acid. These are the general properties of interhalogens. In exam, you have to write 4 to 5 points. Okay, interhalogens. Next, stereochemistry and structure. Okay, na? Stereochemistry and structure of interhalogens. Okay, na? In AB type, AB3, AB5, AB7. AB, AB3, AB5, AB7. Inni types, okay? These types ఏందనేది మనం నేర్చుకున్నాం. Okay? So one by one. Okay? In AB type, interhalogens ఏమేమి ఉంటాయి? ICl, IBr, iodine chloride, iodine bromide, iodine chloride, iodine bromide. See, first one is iodine chloride. Okay, na? Iodine chloride. You know the iodine is 5d10, 4d10, no, 5d10, 5s2, 5p5. Iodine is 5d10, 5s2, 5p5. 5 is 0, we get 5s2, 5p5, 5s2, 5p5. See, in 5s2, there are 2 electron, 1 orbital, okay, na, 2 electron. In 5p5, okay, na, only 5 electrons are required. Okay, na? Only 1 electron is single electron. They are remaining 2 are paired. Okay, reaction with chlorine. Okay, na, ICl between iodine and chlorine. Chlorine is 3s2, 3p5. Because atomic number is 17. Okay, na? 1s2, 2s2, 2p6, 3s2, 3p5. 3s2, 3p5. So this is also 3d0. There are no electrons in d orbital. No electrons in d orbital. This is also 1 single electron and 3 paired electron. Okay, na? Paired orbital. Okay, na? 3 orbitals are full filled and 1 orbital is singly filled. Okay. Next one. See the PZ orbital in iodine and P. Okay, na? So P orbitals are classified into 3 types. What are they? PX, PY, PZ. PX, PY, PZ. The PZ orbital of iodine and chlorine overlap. PZ orbital of iodine and chlorine overlap, forming of sigma bond, like iodine. Okay, na? Like the resulting molecule is linear. See. Okay, na? Empty orbital. Okay, na? Empty orbital of PP overlap form sigma bond. ICl structure is linear structure. AB type. Good pettukondi. AB type is linear structure. Okay, na? AB type is linear structure. AB type is linear structure. Okay, that is AB type. Next one, AB3 type. AB3 type. See, in AB3 type interhalogens, what are they? ICl3, ClF3, and BrF3. Only 3. Okay, na? ICl3, ClF3, and BrF3. The oxidation state of central atom is +3. So I already discussed. Okay, na? AB type +1, AB3 +3, AB5 +5, AB7 +7. Okay, na? In AB3 type, the oxidation state of central metal ion is +3. So it contains 3 unpaired electrons. 3 కాబట్టి 3 unpaired electrons which are obtained in first excited state. The atom undergoes Sp3d hybridization. Sp3d means 1 s orbital, 3 p orbitals, 1 d orbital involving. Sp3d means with 0 lone pair. The shape is trigonal bipyramidal shape. Okay, Sp3d hybridization to form Sp3 hybrid orbital. Okay. So see this Sp3 hybrid orbital 2 which contain the pair of electron has 2 equatorial position in triangular bipyramidal. The 3 pz orbitals are smaller atom overlap with sp hybrid orbitals of form sigma bonds. The shape is T shape. Okay na? For if a Sp3d shape is like this, this is metal, chlorine, L ligand, and ligand. Okay na? This is trigonal bipyramidal shape. But only in ICl3, only iodine, chlorine. These are 2 lone pairs. Okay na? See this. This is central iodine. Okay na? See, iodine ground state is 5s2, 5p5, 5d, 0. But in iodine Cl3 is nothing but 3 negatives is converted into iodine is +3. +3 కాబట్టి 2 electrons. Okay na? 1 electron. Okay na? This electron shift into 5d1. This electron shift into 5d1. That's why 3 single electrons, unpaired electrons are there. So 3 single unpaired electrons are involved in this hybridization. So that's why Sp3d trigonal bipyramidal shape. So actually first excited, but there are 2 lone pairs. See, 1 lone pair, 2 lone pairs. Okay na? 2 lone pairs are occupied. Okay na? At lone pairs are occupied at equatorial position. So that's why the shape of ICl3 is considered as T shape. See how the T shape is. So these are the like this is T shape. You see that like this. Okay, you see like this from this way. You see T shape. Okay, now because these 2 are lone pairs. It has 2 lone pairs. That's why the ICl3, AB3 means AB3 type interhalogens is taken as T shape. In AB type only linear. In AB3 act as a T shape, but actually trigonal bipyramidal. But it contains 2 lone pairs. Okay, now it look like as T shape. This is the structure of ICl3. Okay. So you know that this one is number 1. ICl is a linear molecule. Yes. Simple ga. What is the shape of the molecule? Linear. Okay na? Sp3. 1 minute. ICl, iodine is 7th group element. So we are countable as 1 chlorine. These 3 lone pairs. Okay na? 1, 2, 3, 4. 4 means Sp3. Okay na? 4 means Sp3. But 3 lone pairs is considered as linear molecule. Sp3 hybridization and 3 lone pairs is considered as linear molecule. But in ICl3, okay na? In ICl3 or AB3 type, AB3, ClF3, BrF3, ICl3. These three are considered as T shape and Sp3d hybridization. And the oxidation state of central metal ion is +3. plus 3. Okay, so these are the AB3 type structure of AB3 type. So we'll continue tomorrow remaining interhalogen structure and pseudo halogens also. Only these two are very, very important. And what is the properties and what is interhalogens, preparation, properties, classification. Preparation, properties, classification, and pseudo halogens. Pseudo halogens also important. Okay, right. Thank you. We'll continue tomorrow, same time.